Okay, we are in week number 5 for the safety course, and this week we are talking about safety circuits and safety devices. So a continuation of our safety circuits and devices. I get my pen operational here. Use a blue pen. There we go. Alright. Go back a bit here. So, a little bit of a review. We talked about control systems and what they do. We talked about safety-related control systems. In particular, different examples of safety functions. We talked about normally open versus normally closed, dual channel versus single channel, how a relay functions. We talked about that last week. And then we talked about the basic safety circuit, and we also talked about the problems with this basic safety circuit, because we pointed out that this has 3 points of failure. So when we're talking about points of failure, we're talking about individual items that can fail that basically cause the entire circuit to fail. So basically, if this EStop were to fail, my whole safety circuit doesn't work. If this relay were to stick closed, that whole safety circuit doesn't work. If this one relay contact were to stick closed, this whole safety circuit doesn't work anymore. So this makes it, we're going to say, not control reliable. And so this would be okay for low-level safety applications, but not for higher-level safety applications. So when we talk about safety circuits, we always want to have redundancy, diversity, and monitoring. So what can we do for a better safety circuit? So this one here, this is a good safety circuit. So the reason why this is good, it has redundancy and cross monitoring. So we will show you exactly how this would work. So this is much more complex, but if you look at it, basically the same thing. This is our basic start-stop circuit. So we have our EStop button here, our relay here, which has this bypassing or latching circuit or latching contact there. Instead of the start button, we've replaced this with another relay here, and then basically what we're doing is we're duplicating this entire circuit right here. Okay, so that's basically the same thing over again, and you will notice now that we actually have my controls for this are right behind the camera, so it messes me up when I go to grab things. So this EStop button, this is one device with 2 sets of contacts. So 1 set of contacts, 2 sets of contacts. This is a dual channel device, which allows us to run 2 separate circuits off of one device. So pushing this EStop button will break both of these circuits at once. So this is basically circuit number 1, this is circuit number 2. What we also have here, you can see this is CR1, CR2, this is CR2, this is CR1, so those work together, and then I also have CR1 and CR2 right here. So this is my equipment. This is what I'm ultimately trying to energize. What conditions do I need to actually get power over to there? So I would need to get CR1 and CR2 both energized. And I have this third thing now, CR3, which is a normally closed contact of this relay. What is this relay? So this is now where my start button is. And you can see I also now have a normally closed contact of CR1 and CR2 right here. So let's take a little walk through this and go through what actually happens with this when we are in the de-energized state. So let's look at this. Let's say that we are de-energized. Where do I have power if I'm de-energized? So if I'm in the de-energized state, I have power here, this is basically all lit up if I am in a completely de-energized state. Okay? Now, as soon as I press, now because CR1 and CR2 are off right now, I also have, basically, I have continuity across here. I have continuity across here. CR3 is off right now as well, so I also have continuity across here. Now, as soon as I press this button, what is going to happen? I press this button. That means I now get power through here. This is good all the way through here. It's a series of events that happen here. I now get CR3 to close. So this is now energized, and it will close. So CR3 closes. That means I get power across here and power across here. So I get this, this comes in, and this comes in all at the same time, which means this comes in and this comes in. When that happens, this closes and this closes, which means I get this. This is my bypass here. This is my bypass here. This is on, this is on. Gives me this. And I now get my equipment powered as well. Now what this also means, when this breaks, I will now suddenly get these circuits here will open because this is normally closed, CR1 and CR2. Sorry, I don't get this yet. Don't get this yet. When this breaks, this goes off. So now I lose that. That going off now closes this one. And now I get power to here. So this now gives me power to the equipment. Okay? And I will stay energized like this. The only thing that's going to break me out of it is pushing this EStop here. Okay? So essentially this works like the other safety circuit that we had, but with a couple of key exceptions. So let's look at what those exceptions are. So remember, we had 3 points of failure. On the other one, so let's examine what those points of failure are and how they aren't affected here. So the first one was looking at this EStop. So if we are energized, so if we are all running, and for some reason this is jumpered here, okay, so we cannot break this circuit here because this is somehow shorted out, that EStop is not working. This is a dual channel device, so we can still break this circuit here. Now if we are able to break that here, so basically this circuit is going to operate okay, this circuit is not going to operate okay. However, we need both of these relays functioning. Even if this one doesn't function properly, but this one does, we need both of these relays functioning in order to get power to the equipment. Okay? So that is one way where EStop fail, we have that covered. Let's look at another failure that we talked about earlier on. We talked about the possibility of this relay, or one of these relays, sticking. So let's say this relay stuck in the closed position. So we're running our circuit, we hit the stop button, this relay opens up again, this relay doesn't. So that opens our circuit, and we de-energize power to the equipment. In order to restart the equipment again, we need to see CR1 and CR2 both actually transition from open to closed, because we need to see open in order to run, but we need to see closed in order for us to actually be able to run this reset circuit. So this is where we get into monitoring. So we need to be able to see this relay actually transition. We need to be able to see it go from this state down to this state, back to this state, in order for us to reset the whole circuit. So if we do not see this ever go into this phase here, if we don't see it go off completely, we won't be able to get this, which means we can't get this, which means we can never get these, which prevents us from ever being able to restart the circuit again. So this is called monitoring. Alright, so we're actually monitoring to make sure that we are always able to transition these relays. So that is covering us against sticking relay coil. So the dual coils with the monitoring prevents that. Now the other thing that could possibly happen is if this contact here were to stick closed, but because we are using two sets of contacts, 1 and 2, in series together, we need both of these to function properly. If one of them were to stick closed, we still have the other one that is capable of functioning properly and being able to stop our circuit. So that is guarding against sticking relay contact. So those three cases of potential failure that we talked about with the single circuit, this dual circuit protects us against all three of those cases. Okay? So lots of advantages to using this type of circuit, and we call this using three force-guided relays. Now, disadvantages to this circuit. Won't get into that. This is much more complicated to actually wire. This lists out 38 individual wiring points if you were to try to wire this together yourself. So there's a lot of potential for wiring errors. It's a lot of labor to actually install this. We're talking about 3 separate relays, where before we only had 1. You have more cost, more panel space. Fairly easy to bypass this. You could actually just put some jumpers in here still. You could just completely jumper that out if you wanted. There's no short circuit protection on the inputs. It says that reset is not monitored. That is true. You can actually jumper that out still. It's difficult to troubleshoot, and the more contacts needed, the more complicated the circuit. So there are some issues with this still. Okay, so functionally it's good, practically it might not be as good. Now what we have done as technology has advanced, we've created these devices called safety relays. So this basically contains all that same circuitry, but in one very small device that we can wire, and basically all of that circuitry is basically contained within a very small device. These things are physically about typically about 22 millimeters wide, so they're not very big. So these have redundancy and self-monitoring right inside, and diversity comes from the devices that you use. So using a two-channel EStop or limit switches or something like that as inputs to these gives you the diversity from them. This is what the internal wiring of these look like. So you have your EStop, you've got a reset, and you've got multiple contacts on the inside that allow you to operate this thing. So that is a safety relay. A safety PLC is a more modern version of this because we can do a lot of different safety functions all within software. And all the redundancy and self-checking are all internal to that. More expensive to do it this way, but this is the way almost everything is done now. Safety PLCs came around probably into prominence maybe around 2010, maybe about between 2005 and 2010, I would say. And this is pretty much the way everything is done now, unless it's a really small system as safety PLCs are being used. So let's get into the actual devices that we use with these safety control systems. First one we're going to talk about is the EStop. So EStop is basically just a two-channel push button. Function is intended to avert harm or reduce existing hazards. Typically an EStop, like you can see here, going to be red with a yellow background to it. Typically dual channel. And there should be one located within reach wherever you have somebody working. Okay, now one thing to remember about EStops is they're actually not they are active devices, not passive devices. So you actually need someone to push this. This does not prevent harm from happening. It basically stops the machine after something has already happened. So basically everywhere you've got somebody working, you should have an EStop that they have access to. So if you've got 3 people working on this machine, there should be 3 stations with EStops on it within reach, one within reach of each person working. Alright, another device here, the emergency stop, the cable switch. Okay, cable pull or rope pull. This is like an EStop, but it's activated by pulling a cable. Often compare this to the thing you pull on the bus to indicate that when you pull the cable on the bus to indicate that your stop is coming up. Those of you that have ever ridden a bus before, like you can see this guy pulling the cable here. Now the benefit of these, if you have a really long conveyor system, like let's say you have 100 feet of conveyor, you don't want to have to put a dozen EStops along this. Okay, you don't want to have to do that. What you can do is just put one device here, and then run this cable along the entire length of the conveyor, and anywhere along here that you have a person working, they are able to grab this cable and pull it, and it will activate that stop to stop that conveyor. So commonly used along long stretches of conveyor. Safety gate switches. This is what we use to detect if a door is closed. So there's a couple different types of these. These ones here are a magnetic or an RFID type. So there's no contact between these two pieces. Basically, if this piece here is in close proximity to this piece, it tells us that the door is closed. So you mount one piece on, you've got a door like this. It swings like, moves like that. You put one piece here, and if they line up together, then everything is good. The other way you can do this is you get these ones with a little metal key that actually plugs into the rest of the gate switch. You can see that key there. And you mount that onto the part that moves. Two different types here. This larger type here probably has a solenoid that actually locks this in place. So if you want to open that door, you would actually need to request that door becomes open, and then it will actually open the door for you. So the way we would do this, if we had a cell with doors on it, and we got like a robot working away inside here, we would have maybe a door switch here, and a door there as well. So we need to make sure that both of those gates are closed in order for this robot to be able to run. A couple different configurations of them there. Typically all these devices are going to be 2-channel. A light curtain. A light curtain is basically 2 sticks like this with invisible beams that go between them. If you put your body or hand or whatever between those beams, it breaks the beams and it knows that you're there and it stops the machine. So typical application for this. We've got some type of cell. And we are going to put these sticks here, and then the beams go between there, and if someone comes along and tries to walk in between here, we do this instead of a door because it's the path that we want to be able to walk through normally. But if somebody does walk in there, we want to be able to stop. But we do light curtains when there is something where we want to be able to walk through there on a regular basis without going through a door. But if we walk through at the wrong time, we don't want it to, we want things to stop. So here's a case of basically making a wall around a robot with light curtains. You can also use mirrors. You can bounce them off of mirrors to do that. Here's a case where we have hard guarding on the sides and light curtain across the front like that. You can do lots of different configurations like that. There is calculations that we'll get into later in this course of how far these light curtains need to be away from the hazard. So how far that distance needs to be for them to be considered safe. And all these channels, all these devices are 2-channel. Here's another one, the area scanner. This thing here looks like a coffee pot. This is an area scanner. What this does has a laser inside it that spins around and detects distance in every direction, and you can program this to whatever shape you want it to be. We use this to protect abnormal shaped areas on a floor. You'll also see them a lot on AGVs, so automated guided vehicles. So a little vehicle that drives around on its own, put this on the front of it and it can scan to detect if somebody walks in front of it. You can also use it if you have a cell that you want to guard. You can stick one of these in the corner and have it scan like an area like that, and it basically scans there and tells you if somebody has walked into that area. These are expensive. Okay, we had a battery change on the camera. Now we're back. Continuing on with talking about area scanners. So basically this will scan an entire area to tell you if someone has walked into that area. Similar is a safety mat. What this does, this is a pressure sensitive device here. And you can make these you can get them in whatever size you want. And this basically works by, if you step on this, it can detect that you have stepped on it. And it will give a signal to tell you that you are in an area you shouldn't be if you step on it. Now, problem with this, of course, if you have a big area, it gets pretty expensive. Like we talked about the area scanners, a single scanner can be up to about $4,000 for an area scanner. But a safety mat probably only going to cover a very small area. So if you need to cover a big area scanner is probably a very good option. The other thing with these is you can't really go around shapes. You have to buy them in the shape that the area mat is. So if you have a nice rectangular shape or something like that, you want to put it in. Works pretty good. If not, the area scanner is configurable to whatever shape you want to have. Another thing here, a contact bumper. What this is, let's say you have a door, like a big sliding zip door that goes up and down like this. You'll see this on garage doors and stuff like that. You put this bumper strip on the bottom here. Now what that does, that detects if this door, when it travels up and down, if it ever comes down and hits something, this contact strip will detect that something is jammed in the way. And if you hit that, it'll sense that you've hit something and it'll stop the door. So that is a contact strip. And our final device we're going to talk about, these controlling devices, such as an enabling pendant. You'll see these on our robot cells in the robot lab. We use these we have them on the teach pendant. You need to squeeze them, and you actually have 3 different positions to them. So if you picture you're squeezing this button, so it has like basically like a trigger to it. So you squeeze that trigger like this, and it has, if you squeeze it too far, that will trip it. If you release it completely, that also trips it. You have to squeeze it, but just hold it in the right position and maintain holding it there in order to be able to let the machine run. These are very common on robot teach pendants. The reason we like that is because when you're holding the pendant, you need to basically be squeezing it to have the robot enabled. If you were ever pinched or if you're trapped by the robot, so if the robot hits you and you let go of the pendant, that will make it stop. if you ever get hit, but you're actually pinned, and in that pinning action, it makes you squeeze, that will also cause a stop. So this is a 3-position device. Hold to run, let go to stop, or squeeze it to stop as well. And like we said before, 2-hand control devices is another type of device here. So you can see on this little punch press, you have 2 buttons here. I'm just gotta get my eraser here. All right, eraser, where are you? But basically what this does, if we have a guy right here, he has to have one hand on each of these buttons in order to be starting that machine. If he's got a hand on each of those buttons, then we know he doesn't have a hand in here where it is dangerous. So if he's pressing both these buttons and is required to press both buttons in order to start, then we know his hands are in safe positions. Okay, so that is 2-hand control. So this video that I'm going to show here, we'll see how this plays. This is going to show you the most complex machine that I've ever worked on for safety. So this was on a casting cell that casts, so when I talk about casting, this is making sand cores and then pouring molten aluminum on them to produce cylinder heads. So this is a casting machine in an automotive plant. So there's a tremendous amount of safety devices involved with this machine here. So let me move this over a bit so I can actually get to where I can see this here. So I'm going to play this video. So I'll point out all the different safety devices we've talked about here. So you can see that robot reaches through the door. Whoops. Now, when we're reaching through the door, so what are some of the things that we have here? First thing we'll notice, up here, there, and then we have one on this side as well. These are door limit switches, so that detects if this door is all the way up or not, because when it's all the way up, we have our perimeter guarding okay. So we want to be able to have a safety device that detects the position of that door. So that is a safety gate switch right there. Let's keep going here. That robot drops off those cores. It's going to come over here. Now we're going to see it is reaching into a spot where this spot, that sand core that just got picked up, that's manually loaded by an operator. Whoops. Now, we can see here, this device here, because that is a manually loaded station, that device there, that's a light curtain. So we have light curtain beams. They're invisible, you can't see them. But basically there would be light beams going all the way across here. So when the operator reaches through here to load that part that just got picked up, we want to be able to detect if someone has their hands in there, because we will not allow the robot to go in there if somebody's hands are in there. Okay? Or if somebody reaches in while the robot's in there, we want to stop everything. So this is our light curtain. We'll continue on here. You'll notice here we have an EStop on that box there. Whenever we have an operator, we're going to have an EStop. So red button, yellow background, that's an EStop. Robot moving around. This is actually scooping molten aluminum. I have a furnace here. You can see that's lifting aluminum out of this furnace. That aluminum is about 600 degrees right there. And that will be solid in a couple of seconds, so this has to go pretty quick. So we're going to move across here. This device here. See another device here. These red devices on these doors, that is a locking door switch. So you need to request to open this door. When we say request to open, this is solenoid locking. So you need to push a button, and this will not unlock unless this robot has completed its task and is sitting back at a home position and is ready for someone to actually enter the cell, and then that this would unlock and you'd be able to open that door. Opening that door would then break all the safety. Okay, but we don't want you to be able to do that while this robot is in motion. Alright. Release that. And you can see this. And here we go. Here's another example of that is our door switch. And this box here, we've got an EStop. And this would be our request to enter button for this door. You'll actually see this pouring the aluminum in the mold here. So you see that flowing in there, that's all molten aluminum. Now this is actually going to come back here. It's going to blow some air to clean this out. And this is about 5 minutes later on the other side of the machine. So this was liquid a few minutes ago, and now this is a solid at least a solid enough metal part to be lifted out. I think this is still about 300 degrees when this comes out of here. So this is a mixture of sand core and very hot aluminum. Let's put in this rack to cool off. And we grab some that are already cool. A couple things you'll see here. We're going to run these into a big saw area here. So a couple devices you'll see. We go around here. Alright, this here, this little conveyor section. See this red cord right here. There's one here, you'll see one on the other side as well, on the side of this conveyor. This conveyor is not very long at all, but this has, by their spec in this plant, they require all conveyors to have cable stops on them. So you'll see the cable stop. So you can see here, that's the one end of it, one end over here. Whoop. Oh man. That's the other end of it right up here. So the cable goes into that, and it's basically just like an EStop device. You can see more things here. Again, EStop, EStop. This is the robot controllers. You'll see a teach pendant here. Gate switch. This is the big saw in here. Here's another interesting one in here. If you want to go into this area, you need to wait. This terrifying machine over here. This is this huge, big spinning saw blade. So this basically cuts pieces of this metal off. That's like a big table saw that just spins, and we drag the this big metal part through it. So if you want to go in this cell, even if we try to stop this saw blade, it takes about a minute for that blade to come to a complete stop. So we have a device on there that we call a zero-speed monitoring switch that detects if the blade is stopped or not. So we need to wait till that comes to a complete stop before we will allow that door to unlock so you can even go into that area. Okay, so that is a zero-speed detecting switch. You can see at the end here their cable EStop again right there. And then at the very end of this process, a whole bunch of light curtains. So you'll see, I think there's 2 sets of light curtains here. So you have a set of sticks here, another set of sticks here. So there's like one set of beams here and another set of beams out further that this part is going to travel through. So this is just verifying that nobody gets up on top of these conveyors and is able to walk through it. So there's a good shot of it there. So this is light curtain. So that would be projecting beams across there. And there's another set here. You'll see another set out here that basically gives another field. So you are allowed to break one of those but not both. So that allows a part to travel through. So the part is allowed to break through one but not both sets at a time. So you'll see it'll break the first set, broken, and then clear. And then there's another set over here. Okay, so that is a whole bunch of safety devices all on one project. Okay, so that is our introduction to safety devices.